Hello, everyone. Good afternoon, good evening, and good morning to you, depending which time zone you are in. Today, we'll have Andrew with our Jakarta Tech Talks today on utilizing MicroProfile health checks in a cloud environment. So without further ado, I'll let you take it away, Andrew.
Hi, hopefully you can hear me clearly. Right, so yeah, my name is Andrew Pilaj, and this is MicroProfile Health Cloud demo, giving a quick overview of using MicroProfile Health in a cloud environment. So there's my details. I'm a Java developer at Pyara Services. You can contact me on Twitter there, though I never look at it. So just a little bit of background first. So cloud obviously has essentially become the industry trend in recent years for hosting your web applications, in comparison to hosting them on premises on literal hardware you have in your office or in a server rack somewhere. The reasoning for that is there's numerous ones, but it's got a lower bar of entry because you don't actually have to spend thousands of pounds or dollars on buying out a massive server rack and setting it all up. That's not to say that cloud is necessarily cheaper. Depending how you use it, it can be more expensive. It's cheaper with asterisks. But it brings various other benefits as well, such as easier setup and maintenance, easier scaling, just because of the fact that it's all done essentially via interface, and the various cloud platforms are actually dealing with all the groundwork for you. So some of the cloud platforms you've probably heard of: AWS, Amazon Web Services, Azure, which is done by Microsoft, and Google Cloud Platform, which is obviously done by Google. But then there's also containers and orchestrators, as I like to call them. I don't know if they've got a technical name or not, which is things like Docker and Kubernetes. These are, again, very much coming into popularity in recent years, where in comparison to having full VMs, even in the cloud, you instead have containers, which have some advantages. The main one being that they are less susceptible to just small variations in the environment. There's the quite famous meme or joke of it works on my machine, then we shall ship your machine, and that is how Docker was made, essentially. But there's those, and then there's also some of the other services provided either by Amazon or by other companies such as Red Hat. There's OpenShift and Fargate, which tend to be kind of hybrid things of OpenShift, particularly is using Kubernetes on in Red Hat's cloud environment, and Fargate again is a kind of slightly different take on using it. It's a serverless thing rather than setting up your full VMs and managing them via the AWS EC2 console. So microservices as well, as one of the, just a very quick background of that. Again, popular architecture, seen as one of the go-tos in architectures for cloud environments. The reasoning being that in comparison to a monolith, or which has one or very few apps, big apps with multiple moving parts and layers, microservices are intended to be a lot smaller and more focused to give easier maintenance and greater flexibility. It's not always necessarily a good thing to be using microservices, particularly if you're actually moving across from an existing monolithic app. There are many pitfalls which are frequently fallen into. The biggest one probably just being that you are moving from a monolithic app to a microservices architecture. They are not one and the same. It's not easy at all to switch from one to the other, just because the design is very different. But microservices, they as mentioned, they're smaller, more focused. They allow you to more easily kind of just develop individual parts of your application independently, and even deploy them independently, because that's the actual intent behind it. So you've got multiple bits of your application, of your greater application, deployed independently. So monitoring of those can be quite complicated. It's one of the age-old problems with actually running systems and applications in production, of how do you know when it's going wrong or gone wrong. So one of the main ones, which you're probably all familiar with, is simply just the machine health of, is it sat at 100% CPU usage? Is it sat at 100% RAM usage, or has the storage completely filled up? A lot of those metrics are actually provided by the cloud providers, such as AWS. They frequently have basic levels, which is normally free or just extremely cheap, which is quite literally that it's set at 100% CPU usage. And then they typically provide more in-depth ones as well. And those in-depth ones typically have some sort of link into notifications, which is the second way of monitoring of, once you've got your monitoring set up, how do you actually know about it? How do you get notified of it? Again, most of the cloud providers give some sort of notification system, and if they don't, one of the common ways is just simply within the application server itself set up notifications, as most have some form of emailing you or otherwise notifying you. But this leads me nicely into from application servers to the actual applications. Although yes, the machine may be sat at 100% health, 100% usage, that's not necessarily indicative of what the actual application state is. It could be in a zombie state, or it could just simply not have been deployed and something else has kicked it off to 100% CPU usage, such as our age-old favorite Windows updates if you're running Windows Server. So there are various ways of monitoring applications. You can literally just see the timeout of, oh, it's not working when you hit the actual endpoint, or it's just being extremely slow. So literally you try to use the app and it's not there. It's a form of monitoring in a sense. I've already mentioned there's application server metrics. This tends to be things like thread pools. So you've got a bit more fine-grained knowledge of what's happening, of why your application is potentially not responding, such as the thread pools are completely filled up. And those typically can be exported into third-party monitoring solutions, such as Prometheus or something like that, or Grafana, to give you a nice graphical view. And then obviously you can just manually define the checks yourselves, either within the application or on the server itself, of just going, set up a cron job which pings it and then goes, oh, it didn't respond, send an email via bash script or whatever. But why bother with that when there's MicroProfile? So again, a very quick background. MicroProfile was, sorry, ice cream van going by. MicroProfile was an initiative kicked off essentially because at the time Java or Oracle, who owned Java EE, were being very slow in response to things and actually being quite opaque, essentially not telling anybody what they were doing. And the whole process for actually contributing and steering the direction was quite closed in. So that initially kicked off MicroProfile as just kind of its own thing within Eclipse, where it's a lot easier and it's a lot quicker moving and it's not tied to Oracle. Obviously, Java EE is now moved over to Eclipse and is now Jakarta EE. But that does not necessarily mean that MicroProfile is moving back into it at all. If anything, I've heard through the grapevine, it's very much going to be staying separate from Jakarta EE. There are quite some strong opinions that it should remain separate, it should remain faster moving, but still it keeps using it. For example, it uses JAX-RS from Jakarta EE or Java EE. So MicroProfile, it's, as its name alludes to, is very much designed around giving application developers an various APIs for actually developing applications for microservice architectures. One of these is MicroProfile Health, which was, although not all of them are designed for use in cloud and containerized environment, MicroProfile Health most definitely was. It's quite closely tied to Kubernetes and the other cloud providers, in that it gives you an API which lets you define various checks that you can trigger. So it gives three different, at the moment, it gives 3 checks. In future, this will probably be dropping down to 2. It provides readiness checks, liveness checks, and then generic. They didn't really have a name. They were just called health checks. But they were just generic. Those are the ones which are deprecated. Readiness checks are intended to be used as essentially, is your application started? Is it running? Is it actually ready to be begin servicing requests? And liveness is, as the name alludes to, is just literally, is the application still running? Is it still healthy? Is it alive? The generic ones, which is why I've called them generic, they didn't have this distinction. They were just literally generic ones. They were accessed by poking an endpoint. But with the introduction of readiness and liveness checks, that endpoint has been split into 2, so that you can actually differentiate between the readiness and liveness checks. Although the functionality is still there to just run through all of the health checks by hitting the original health endpoint. It's not been removed yet, which kind of getting ahead of myself. The health API, although it's not on the actual application developer side, those who implement the API have to expose an HTTP endpoint or HTTPS if you want it to be secure, which when you poke it, it will run through all of the health checks that you've defined within your application. So it will run through readiness checks, liveness checks, and the generic ones. Originally, this was just the /health endpoint, but now you can specifically only run the readiness checks and specifically only run the liveness checks, or get all of them still. So a little example. So rather than just me saying it, I've written up a very, very basic health check. I will specify this. You should not be writing a health check like this at all. I'll be using this in the demo today. But this essentially, you define your health check, you implement the health check interface for your class. In the case of CDI scoping, it needs to be scoped to CDI. So in this case, I've just done it as application scoped. And then depending on if you want it to be a liveness check or a readiness check, you annotate it with liveness or readiness. You can actually specify a check as being both. What that simply means is that if you hit the health ready endpoint, it will appear there. And also if you hit the health live endpoint, it will appear there as well. So the general way this API works, aside from implementing that and annotating it with liveness, is, as you can see here, you override this one method, health check call, which returns a health check response object. You create using a response builder, you create your response, give it a name, define the state of it with this method here, up or down, and then you can provide additional data if you so wish, and then build it to return it. So rather than me just talking, I'll load it up here. I've got it open in my browser here, browser IDE. So this with data method It's not just string. If you wish, you can provide longs, booleans, or strings. Essentially, you can just fill it out with as much metadata as you want. And then the up is used to define that everything is healthy, and down is used to define that everything is down, essentially not healthy. And then you build them. So this, as I said, you should not be having a health check like this, because this is essentially, as the name implies, a coin flip. It just creates a new random and just goes, is it up or down, essentially flipping by flipping a coin. More useful ones would be ones utilizing actual liveness checks around did it respond within, let's say, did it respond within 5 seconds or something like that? You can define that in your application, or you could define that in the cloud of did it actually respond. So the original, if you're coming from the older versions of the API, there is still the health endpoint. As you can see there, it's crossed out because it's deprecated. As I said, though, this is the generic one. It is deprecated. This is essentially the equivalent of just defining it as both a liveness check and a readiness check. Read that again. So I've got that built. So if I deploy that, I'm going to use, obviously I work at Payara, I'm going to be using Payara Micro. So I've already built it. I'm not going to bore you with showing me use Maven Clean install again. But I've downloaded Payara Micro. I set it no cluster because I don't need the clustering, and make it load up quicker. Set the context root to root so that it's just, I don't have to specify the application name, and then deploy it. And then once that's started up, should be able to go to localhost 8080. Started up. Got the index there. And then the endpoint, as I mentioned, is under health. So if I hit health, this would run through every single check. This would run through all liveness checks and all readiness checks. I've only got the one in this application, but you can see here the coin flip went well. I got a heads, essentially. So it's given a status of up. So this is in JSON as well. So if you want to read through it using a JSON parser, you can, which is the actual use of the metadata. So it's given a status of up. Just run the checks, so the name fragile, status up, data there. And if I just hit this a few more times, eventually the coin flip will come up tails. It shows down. So as mentioned, this is a liveness check. So the endpoint specifically for checking liveness checks is health/live. And from memory, I think it's ready. Yes. The endpoint for checking readiness checks is simply health/ready, but I don't have any readiness checks, so it shows as up. So there is no way of specifically going, I only want to, if I had multiple health checks, let's say I had a health check called solid rather than fragile. There is no way of me simply going, give me the liveness check called fragile, or give me the liveness check called solid. There is no way of doing that. The intent is not for you to be able to go through and manually go, what's that one doing? What's that one doing? What's that one doing? It is essentially a full, what is it? What is the state of the entire instance? The API as well was designed around not necessarily supporting multiple applications, although it does in the case of Payara Micro. So in the same manner that there's no way of going, give me all of the liveness checks for the application 1 and exclude the other deployed applications, there is no way of doing that. It searches through all the deployed applications and gives you runs the health checks for all of them. as I said, this is intended for microservice architectures. You're not necessarily meant to be deploying multiple apps to the same application server in such environments. Nope, that one. So, missed the point as well. So although it's not showing it here, just because of the fact that I'm just poking it with a browser, the up requests return HTTP 200 success, as you would expect. It's just bog standard, it worked. The errors though, so down, when it gives a status of down, this returns an HTTP 503, which hopefully we'll see later. But it's just to say it's unavailable if you don't remember your HTTP status codes off the top of your head. I should also mention as well that when it runs through all of the various status checks, it will only give an up state if all of them return true. So because I've only got one, the general status of up will mirror what the status of this one is here. But if you had 3 or 4, the only way to be able to get a overview aggregate status of up would be if all of them provide up. If one of them returns down, then the entire application is determined to be unhealthy. So you need to bear that in mind when you're defining your health checks, in that you need to be careful that you're not necessarily including a fragile health check like this when it doesn't necessarily need to be there. So I'm now going to run through just a very basic demo of setting up an example environment in AWS, showing off, as I said, this application of how to use the Health Live endpoint in the case of load balancers. I'm not going to be covering doing anything clever such as removing dead instances and replacing them with healthy ones. That's for further reading. I don't have, that's not in the scope of this. This is purely just going to be the very basics of getting people started. So from the AWS console, the very first step you need to do is simply actually create your AMI. Because I'm going to be using auto scaling, and I want to define my AMI before I use it, rather than having it defining all the yum installs per instance. So I'm going to launch an instance. Going to use Amazon Linux. T2 Micro is perfectly fine for this. And you're going to kick off one. Going to kick it off into the VPC that we've just got for our dev stuff. Auto assign a public IP. Essentially leave it mostly with the default settings. And then kick it off. So next, add storage. Again, that's fine. Give it a name just so I can find it. So we'll call it Cloud Health. And then for a security group, I'm going to give it one I made earlier. For those who weren't aware, the security groups are essentially just, it's a firewall configuration, essentially, of you define what ports can access it from where. So in this case, I've just made a very simple one of port 80, so default HTTP can be accessed from anywhere. And also port 8080 can also be accessed from anywhere. This is the default port that PyroMicro starts on. And then just anywhere, my IP address as well. So I can SSH in and etc. So I'm going to kick that off, launch now. And once again, here's one I made earlier. I've got an existing key pair rather than defining a new one. This is just so I can actually SSH in without having to specify passwords. So that should be starting now. While I wait for that to start up. The IP address from there. Get ready. So I already downloaded the PEM earlier. It's just in my downloads folder. So I'm just going to SSH using that PEM and the default Amazon user of EC2-user to that IP address. It's not running, so hopefully I'll be able to. Nope, not there yet. A few more seconds. Yep. Once I'm in, I'm essentially just going to be setting up my machine as a template, so I can actually create all my other instances using this template. So to do that, I need to make an AMI, an Amazon machine image. So I'm just going to install all the things I need. In this case, I need Maven, so cd yum install Maven. And through. And I'm also going to be installing Git and Java 8. Although it's installed in Java 11 now, just for the ease of this demo, I'm going to be using Java 8. PyroMicro does support Java 11, but as I said, just for ease of use, I'm going to be using Java 8. So the reason I'm doing all this is, although yes, I could set this up from Docker, I'm intending for every time I start this instance, for it to actually download the latest version of my application, build it, and then deploy it. Already got Java Devel. So, clone my repo. This is currently just deployed to my personal account. At some point, I'll probably move it into the actual example repository of Pyro. That shouldn't take long. There's nothing to the application. I can quickly show you. It is very much nothing there. It's just a pure basic Maven application. In the POM, I'm just grabbing down the Jakarta Web API, so I've got access to the various CDI annotations. And then I'm also taking down specifically the Health API, because that's the only one I'm using. 2.1, the latest is 2.2, but PyroMicro doesn't support that yet. That's coming in the next release, hopefully. As I said, you could pull down all of them, but for this case, I'm only using Health. So this POM is just saying I want the Jakarta Web API and MicroProfile Health. Specifying the packaging as WAS, because I want it as a web archive. The web XML, nothing there. It's just specifying the welcome file of index, which, as I showed you quickly earlier, it's just saying hello. And then my health check there. There's nothing else to it. Good success. Now I'm going to download PyroMicro. Actually deploy from it. hide it from Maven Central for now. And because I'm not going to try and remember how to type that, I'm just going to rename it to Pyara Micro. What I have there is essentially I've built the app and I've got that there. So let's just double check it all works. So micro, Java jar, micro, no cluster, fruit of root, and then so I'll need to get the IP address from here again. Okay, that's working. Perfect. Essentially, that is my template. So as I said, I could use Docker for this. We do provide, Pyara provides a base Pyara micro Docker image, which is essentially just the Git repo is here. Pyara Docker, Pyara micro is on Docker Hub. You don't have to necessarily build it yourself. But if you do want to deploy your own application, this is probably better to build your own thing, and doing so is really simple. Although yes, you could take the full Docker file and edit it to your heart's content. You can also just extend it by doing from Pyara micro and then copy your application into the deployment directory, and then it will automatically deploy it. The reason I'm not using that is because, as I said, I'm intending for this to be building the latest version of my application each time, and that's not in the spirit of Docker. The Docker instance, Docker images are meant to be fairly static. You're not meant to be building things within them each time. They are meant to be immutable, as it was. So now that I've got that, I'm going to stop it because I want to make my AMI from it. So let that stop. There we go. So I don't want to go to actions, image. Yes, image. Create an image. So give it a name of health cloud demo. We're going to give it a description because I'm only using it for this. Keep that and create the image from it. This just means rather than me spinning up the new instance and having to do that each time, or within the startup parameters of the instance, specifying that, I can just literally have it as that. So this can potentially make the actual startup time of your instances quicker because they're not having to manually install Java, Maven, Git, and then build your application, or even download your application. That's typically another issue you have. If your application, for example, is, let's just say 2 gigabytes in size, if you're just using the startup scripts, if you're just defining your instances to start and download that application, each time you start a new instance, you've got to download that 2 gigabyte application. That will slow down your internet or the startup time of your instances. Because although yes, Amazon have big fat pipes, where you're hosting it may not necessarily have big fat pipes. Downloads are two-way. So now that I've got my AMI, I'm going to create a launch template. So create a launch template here. This is, again, very much in the same manner as the AMI. This just lets me define various things so I don't have to define them each time. So define a name. In my AMI, I want to search for my AMI I just created there. Instance type. If you want to specify the instance type, you can either let it define it itself. In this case, I'm going to keep it as the same. Let's keep my original one, just in case I need to log into them. VPC, yep, I'll leave it where it was. I'm not going to select a security group there. I'm instead going to add a network interface, just so it's got one. Specify that I want it the public IP to be enabled. And then what I will do actually is grab the name of it. So that should be taking my notes. Yep. And I also want to specify that I want to use this for auto scaling, just to double check that everything's perfect. Yep. So although, yes, I said I wasn't going to define that I'm going to download everything, I am still going to run a startup script so that each time one of these instances starts, I don't need to necessarily start kicking off Pyara Micro like I just did. So I'm just going to copy paste from my notes rather than type it out to save time. But I will run through it. So just going to run a bash script, very simple. Can I resize this? Yes. Good. So not the nicest bash script by any means, but it'll do the job. So use the specify as bash, move to the home directory, move into the Git repo I've already cloned down, pull from origin master just to make sure it's up to date and got the latest version, build it, move back up, and then deploy it to Pyara Micro. So I'm going to create the new launch template there. So now that I've got that, I could start kicking off applications. Alternatively, I'm going to create an auto-scaling group. Before I actually start creating auto-scaling groups, I am going to make a load balancer, however. So if I go back to EC2, go to load balancers, and start creating one, ignore that one. So I want to make an application load balancer, just because I don't need any of the other things that the web application one gives. So give it a name. It's internet facing, IPv4. I want to specify, yep, that is defined as a port. I don't want to have to specify anything else, as this is the load balancer side. If I was specifying port 8080, it would just means whenever I hit the load balancer URL, I'd be having to specify 8080. I don't want to do that. What I want to be doing is just hitting it as I normally would, and then moving directly from that to forwarding to the port I want. So yeah, keep it in that VPC, and then I'm just going to specify that I want it available in all availability zones for this EU West area. So no, and in this case, I don't want HTTPS. Security group, again, I want Jakarta Tech Talk so that I can actually talk to it. If you remember, I was opening port 8080 and port 80. This is important because if port 8080 wasn't open, or whichever port Pyara Micro was running on, this demo wouldn't work because I wouldn't actually be able to hit the health endpoint or even hit the application. So configure routing. As I mentioned, I want it to forward from port 80 to 8080. I want to make a new target group. Instance. And then here's where I'm going to start talking about the health checks. So this is health checks for the load balancer. What this means is that I'm going to specify on that port 8080, traffic port there, which is that port specified. If I wanted to, I could override it, but because I'm only using that one port, it's fine. Specify health. Just because I wanted to hit all of the endpoints, even though there's only one. The way this will work is if I spin up multiple instances, what will happen if one of them starts reporting as unhealthy is essentially the load balancer will stop forwarding to that instance. So if I have 3 instances and one of them is proving to be unhealthy, as you would expect a load balancer to do, this will mean it's no longer, it will stop forwarding requests to that instance. So rather than relying on any third-party health things or configuring anything on the machine itself or configuring anything within AWS, I'm just going to tell it to go to the health endpoint, and then as part of my normal app development, I've written the health check that I want, where I can actually access the internals of my application. So for example, if I'm, let's say I had a fixed bound array, and for some reason I wanted a health check of just going, that array is now too big, start reporting down, I can actually access that array. Again, that's a very bad example, don't do that. But the option is there if you do want to do it. So the healthy threshold is the number of consecutive health checks that once something is considered unhealthy for it to become healthy again. As I said, this is not dealing with replacing unhealthy instances. This is simply just marking instances whether they're available for talking or not. So unhealthy, so I'm going to leave it generally with these defaults. So once something is marked as unhealthy, it needs to get 5 coin flips in a row to be marked as healthy again, and to be marked as unhealthy, it needs to get 2 bad coin flips. This will probably end up just showing potentially as unhealthy due to the fact that it is literally a coin flip. So I'll leave that there. So interval, all the help information is there as well, and Amazon have quite good documentation, and the options for Kubernetes, Azure are roughly similar as well. They are slightly different, but they're roughly the same. So success codes, if I wanted to, I could specify extra ones, but I just want it as 200. So leave that there. Register targets. I want to, have I forgotten a step? I've forgotten a step somewhere. Damn it. Probably because I should have actually made my auto-scaling group first. So what I'm doing here, I'm just going to start creating my auto-scaling group. So create auto-scaling group. So I went to template, selected the template, actions, went to here. So give it a name. Come back to that load balancer in a second. I think I've done things slightly out of order. Well, I'll just create the load balancer with nothing. Okay. So selecting the template version, the way Amazon works is you can actually keep referencing different versions of your launch template. So by default, it picks the default. The default does not change, however. The default is not necessarily the latest. Default is just by default the very first one there. If you want to change the default or only use the latest, either pick latest or change your default each time. So adhere to the launch template. I'm going to start with 3 instances in the network there. I'm going to specify each of the subnets. Although it only says subnet, it does let you pick all the subnets. And then in here, I want to receive traffic from load balancers. I probably need to refresh because it hasn't picked up my other one. There we go. I did do it out of order. So the health check grace period, this is in the case where you are specifying I want to download a big 2 GB thing. Obviously, that will take some time. I'm not doing that, so I can set the health check period to much lower. I'm going to set it to just a minute. Now I'll set it to 30 seconds. I shall trust Amazon to start quickly. And it's specification don't care about. Scaling policies. As I said, I'm not going to be configuring any fancy removing dead instances or going this instance is running at too high of a CPU utilization, so spin up a new one. I'm just going to leave it as 3 and 3, so fixed size. Not going to have any notifications. This is what I mentioned previously of if something's going wrong, I can send notifications about various things. So in this case, in the case of auto-scaling group, I can send emails to if any of these things are happening there, if it's killed one of the instances or one of the instances is failing to launch. So let's just give it a name so I can keep track of it. Policies, none. Notifications, none. Tags, none. Yep. Create that auto scaling group. Now, hopefully, if I look back at this load balancer, yep, there we go. It's forwarding to my Cloud Health demo target group from port 80. And this will soon, hopefully, start getting various instances. It doesn't have any at the moment. But if I go to auto scaling groups, I've got this one here that I've got 3 instances. I want 3 instances. I've got minimum of 3, maximum of 3, and desired of 3. This is to do with the scaling due to the fact that as I said, I want to be fixed. I've got that there. So if I hopefully look at instances, I will be getting, 3 Cloud Health demos coming into focus now. So if I go back to the load, no, it is here. So once these have started, it will start poking the health endpoint as I specified here every 30 seconds, saying that every 5 seconds if something's gone wrong, giving it a 5-second timer. And eventually, once they've started up and the health checks have started going, we should hopefully, so 503, oh, they've all gone unhealthy. 503 is probably the fact that it hasn't got there yet. So because of the fact that I am, as I've mentioned, doing a coin flip, this is the version of the application I'm using as well. So it's a slightly weighted coin flip, but it is still essentially a coin flip. And the fact that I've set the health checks to be quite harsh, I need it to pass 5 times in a row, it will be quite hard for it to move out of the unhealthy state. So what I will do, just for demonstration, is change that. So you can change these on the fly. Change that down to not timeout. As well. But if I go to instances, they should now be running. Yes, they are. They should hopefully be accessible. Go to health. So as I mentioned, this will poke it each time. If I check my targets again, they're not playing ball. They're remaining unhealthy. 502 is interesting. It should be a 503. Don't know what 502 is getting that from. But what this means essentially is because all of these are unhealthy, if I actually go to the load balancer and try to access it, it'll essentially just give me nothing's there. Oh no, it did find one. That's good. I'm healthy now. Yeah, there we go. They're being healthy now. Because I loosened it. If I'd hit it before, it would have given a 503 unavailable. So that was a very quick look at that. As I said, that is the pure basics. That's not intended for anything like production use. That is just pure demo. Cross fingers. And it did work. Only a couple of hiccups. So further usages, as I meant, obviously this is not just limited to AWS, just for pure time restrictions. That's all I had time to very quickly show in such detail. But this should definitely work. In fact, no, it does work in Azure, and there are options in Kubernetes and Docker Swarm. The readiness checks in particular, the differentiation between liveness and readiness checks, that comes more into focus in Kubernetes and Docker Swarm, where they actually have separate checks for that of going, is the container actually up and ready and serving stuff? Because of the fact that those sometimes, in the case of Kubernetes particularly, depending on the way that's managing its containers, sometimes it will have to potentially download those containers first, which can take some time, getting all the layers and stuff. But as I said, the readiness checks and the liveness checks, that's more focused at Kubernetes. You can use them in some capacity in AWS and Azure, but that's not what they are most pointed at. The readiness and liveness checks are most pointed at Kubernetes and Docker Swarm. So as I've mentioned multiple times in this as well, you can automatically replace unhealthy instances. That is probably one of the main usages for it, along with avoiding the unhealthy instances. If I wasn't using the /health endpoint, I'd have to be providing some other means of telling the load balancer how to know if it's healthy. So just in a very dumb way, I could have not had it directed at the health patch. I could have had it just pointed straight at this index page and gone, that got a server 500 error, that didn't work, and use that as the health. That's quite a brutal and dumb check, though, of just going, is the application working, yes or no? With the health checks with liveness and readiness, you've got more flexibility and more control over how that works, particularly if you start using multiple liveness checks. As I mentioned, you can specify multiple ones. But you can combine it with the machine health and various other metrics. As I mentioned, you can access things within your application. So you could say, can the application itself contact the database that you've got? Can it do a ping? Can it do a get? Is it actually returning data? Because you can, being CDI scoped, it's got full access to all the other beans and stuff. So you can check if your beans are actually returning things. As mentioned, you can combine it with machine health. You can either combine that separately, of define on the in AWS or in your cloud provider general, of just, is it sat at 100% CPU usage for 5 seconds? Okay, that's wrong. But then also have this. Alternatively, you could use one of the other MicroProfile specifications. The metrics is the one that comes to mind. This is specifically around getting that information, such as CPU usage and stuff. So within your health check, I don't have the dependencies downloaded at the time, but I could get the metrics registry within my health check here and start doing those calls and querying the machine state, but also the application state, because the microprofile metrics is not purely limited to the machine metrics. It does give you access to other things as well, such as how frequently something is being hit, among other things as well. It gives you quite a vast amount of different metrics that you can query from here. Metrics is another one that actually exposes an HTTP endpoint as well. So depending on how you want to run it, you could ping the endpoint and see what you get back from there. But yeah, that's a very quick an overview of MicroProfile Health and some of the ways that you could be using it in there. So I've covered a brief overview of cloud and microservices and what MicroProfile Health is. Run through a very quick demo of setting it up in AWS and giving you some further usages. And that was almost to time, 6 minutes under, but pretty much. Thank you very much for listening. Does anybody have any questions or anything else? Because that was me done. So is there, oh, sorry, I wasn't seeing this. Very difficult to see. Somebody's done something. Good.
All right, so if no one else has any questions or comments, thank you everyone for coming, and hope
I
you
see one from Arian hello Arian, by the way. Endpoint health security is now proprietary. Do you think it should be moved to the MicroProfile spec? Is it proprietary? As in things around HTTPS? Ooh, I think that should probably, personally, I think that probably should be moved to the MicroProfile spec. That sounds like something that should probably belong under there. Although, yes, this is MicroProfile Health, as I mentioned way back at the start, it is intended for use more by things such as AWS. There's actually, yeah, the authentication. I lost my train of thought now. Start again. Yes, I do think it should be under there because although if this health is intended for use purely by things such as AWS and Kubernetes, you don't necessarily, if in the case of, as I had in this example, have the IP public, you don't necessarily want everybody else to be able to check the state of your application, particularly if you're sending sensitive metadata over the wire, because you can add anything you want in there. So if you're being a bit thick and sending your passwords as plain text, that should be protected. And yes, by default, the health endpoint is not protected. In Payara, yes, we do support having that under HTTPS, and you can also actually protect that further with logon information as basic Java security stuff. If you're talking specifically around the actual Java security stuff, protection of it, interesting question. I'm going to say no, I don't think that should probably be in there. If nothing else, just because then you're starting to bleed over specs a bit. As mentioned, although yes, there is the possibility of you checking the information yourself. When you start bringing in authentication, particularly for things such as do you have the user rights to access this endpoint, that can get quite complicated when you're starting to use that in Kubernetes and other environments. So although, yes, I like the option of having it there, I don't necessarily think it should be a part of the actual specification, or if it is an optional part of the specification.
All right, perfect. Is there any more questions or comments? We'll give people time to write in the chat if there are any.
That's all people complaining about my resolution. Sorry. I tried to up the size of the text before this, but obviously I can't check for everything. And I wasn't checking the chat, sorry.
Well, anymore. So thank you everyone for coming out. Hope you had a great time. And you can contact Andrew through his Twitter, other social media channels, and this will be up live on YouTube tomorrow. Thank you, everyone.